So we have already looked at how agents work in LangGraph, and we've also looked at what the Graph API consists of. The Graph API is one of the primitive ways you can build agents from scratch in LangGraph instead of using pre-built components. Now, the very first item, we said a LangGraph agent consists of three parts: that's state, edges, and nodes. And in this video, we're going to be looking at the very first part, the state. The very first part, the state. Now, the state is the very first thing that you define when you are defining your LangGraph agent. The state is the very first thing you define, and at the end of the day, your graph is basically just a state engine. So as state passes through each node, it is updated, and at the final point, you have a final state. So let us look at state. Let us get to our whiteboard so that we can have a better understanding of what state is in LangGraph agents. So let's say we have our graph. Let me give this a background. Let's give it a background. Let's give it a mesh background. So let's say this is our graph. Let's say this is our graph. Now, your state is the pieces of data that you need to hold through the session of the agent's operation. Yeah, the pieces of data that you require for the agent to perform its operation. Now, this is not data that is fetched from a persistent source. No, for the duration of the operation of the agent, these are the pieces of data that you need to control its operations. So let's say we have our agent, and the first thing we do is define our state. So we define a state. Let me make this, let's make this solid. So we define our state, and let's say our agent is meant to, let's assume, recommend a bunch of students in a class to be qualified for a field trip. Recommend a bunch of students to be qualified for a field trip. So we can say inside our state, let me get a checkbox for that, or a text box for that. We can say inside our state, we need the total number of students. So I say total num students. We need the total number of students in our state. Let's make this wider. Make this wider too. You know what? Let's just make everything. Let's just increase everything. So I'm going to increase this. I'm also going to increase the box inside. Good. So we need the total number of students in the class. And let's say we want to make them qualify for the field trip based on an average score. So let's say we want to have that average score. Probably they have to take a test. So based on that average score, we need to select students that will be qualified for the field trip. Then we also need to also hold the number of students that are qualifying for, they are going to qualify for the field trip. So let's say qualified students. This is the total number of students that we selected. On and on and on. You can always model your data based on what you require in your state. So we need the total number of students. So we need to count the number of students and just put it in state. We need the average score that will be required. And if this changes, we also want to be able to update it. And we also need a list to hold our qualified students. Let's just say these are the items that we need. Now, this is the state. This is the state of the application. And throughout the operation of the agent, this is what is going to be updated. You can provide initial values for some of them. For example, total number of students, something that can get an initial value. Average score can get an initial value. But while the agent is operating, you'll be selecting students and be filling them into the qualified students list. So this is your state. This is your state. Now, state consists of two things. States in a LangGraph agent consists of two main things: the schema and the reducer. So we have schema. State consists of schema and reducers. Schema and reducers. Probably is more appropriate here. So schema and reducers. That's what a state consists of in a LangGraph agent. Now, what is a schema and what is a reducer? What we just defined, the data model that we just defined with our num students, average score, and qualified students, that's our schema. That's our schema. Your data definition, your data model is your schema. That's the schema for your state. Now, what are reducers? Reducers determine how your state is going to be updated. Yeah, the main function of reducers is to apply updates to your state variables. These are state variables. Total num students is a state variable. Average score is a state variable. qualified student is state variable, and they are all keys inside your state schema. So reducers control how these state variables are going to be updated. And each state variable has its own reducer. Each state variable has its own reducer. There's another video coming up on reducers, so we'll get into that more. For this video, or rather in this video, we're just going to be defining schemas. But like I mentioned, there is a reducer for each state variable. So total num student has its own reducer that determines how it is updated. Average score has its own, and qualified student will also have its own. Now, if you don't apply any reducer to any of these schema variables, there's a default reducer that takes charge. But like I said, there's a whole video on reducers where we're going to be treating that. But for now, let us head into our code editor and see how we can define our state schema. So here in VS Code, we are going to be playing around with different ways we can create our state schema. The state schema for a LangGraph agent. Now, LangGraph provides different ways for you to create a state schema. You can use a plain dictionary. Like I said, LangGraph agent state is mostly represented as a dictionary. So you can use a plain dictionary, a plain Python dictionary. You can also use a typed dictionary from the typing class. So you can do that also. And you can use a data class. Data class gives you the ability to set default values. And also, if you want to go full-fledged, you can use something like a Pydantic model. You can use a Pydantic model, which is very, very awesome and allows you a lot of granular configuration for how your state variables are defined. So in this demo, we're going to be working with a simple dictionary. We're also going to be using a type dictionary, and we're also going to be using a Pydantic class to create our agent schema so that we can see how this operates. We can see these options, and you can choose anyone that is appropriate for your use case. Now, to get us started off, we have a piece of code here that already defines a graph runner. Let's just walk through it. So we import the typical things from LangGraph. So we have state graph to instantiate our state. We have start and the standard start and end nodes. So we have that. Then we have two nodes. We are defining two nodes. Rephrase. Then we have a couple of nodes, two of them that are going to be in this example. We have node A and node B. But before I talk about the nodes, this is how our state is going to look like. Let me just get us clear on that. Now, this state object is not going to be for any particular application. We're just going to be dumping a bunch of stuff inside and see how we can update them. So we have a messages list, which is just a string list. We're going to have a step count. A step count state variable, which is basically an incrementing integer value, or it's meant to increment, but it's an integer value. And we have private data. We are going to have a private data variable also, which is just a string that we can dump anything into. So these are going to be our state variables. But like I said, when you're defining your state, it would represent the data structure that your graph needs to operate. So we have this. Then we have two nodes. And we've named them node A and node B. Now, what does node A do? Node A takes the state. Like I said, every node takes in the state by default. So it takes in the state and it updates the messages list by adding this entry, which is step A completed, and also a step count, which is more like a step counter for the nodes that you hop through. So it also updates the step count by 1. So, then we have node B. What node B does is that it also updates these two items. But like I said, we can use a plain dictionary. So if you want to access a plain dictionary, it's different from when you want to access your schema if it is built with something like a type dictionary or a Pydantic model. So we have to put this check so that we can access one of our state variables and just print it out. This is just for us to print out a state variable, just to show that you can access a state variable inside your node. But the main thing we're doing here is that we're also updating our the two state variables I want to update, that's messages and step count. We're not updating private data here, just to show you that if you don't perform any update, you just have your state that way. And like I said in our graph API video, you only need to return the state you want to update. So you don't need to return the entire state. For example, like I've described above, this state has a private data state variable, but we're not updating it in any of the nodes. So we're just returning messages and step count, which are the ones that we're interested in updating. Then we have this function, which is just a convenient function for us to run our graph with different schemas. We don't want to have to build the graph for every single example that we're going to be doing. So I wrote this function. What it basically does is that it prints the schema that we're working with. It prints the name of the schema, and also if it's a dictionary, it does that check, because working with plain dictionaries is just kind of an outlier. It's like the dark horse of all these examples. So it just prints, oh yeah, dictionary. But if we're using any of the other styles, it prints out the name of the state schema type that we're working with. Then we use our state graph to initialize our state, as we have seen in our graph API video. So we initialize our graph with our state graph using then we had our two nodes, node A and node B. We had our edges. First, we start with our start node connected to node A. So from start, we go to node A. Then from node A, we go to node B. And from node B, we go to the end of our graph. We terminate our graph. So we compile the graph. We invoke it with an initial state, which is passed into this function, build and run graph. So we pass in our initial state, so we use it to run our agent or our graph, and print out our final state. So that's basically what this function does. Is nothing new. It's just similar to how we build graphs. It's just to make sure that we're not writing this entire code over and over for our different examples. Now let us start with our examples of creating a schema in LangGraph. So I'm just going to collapse all these functions so that we can have some room. I think I need to come down out of this function. My scroll bar is very, very fast. Okay, so come out of this and go up and collapse this. Now to our very first example. Our very first example will be using a plain dictionary. Using a plain dictionary. Now for that, I'm just going to simply define a function called create dictionary state or create dict state. And what it's basically going to do is that it's going to return our state, just to return an initial value for our state. So say messages, that will be an empty list. Then we have step count. I'll set step count to 0, which shows the initial point of our node hopping. Then private data is going to be set to none. Just set that to none. So we've created this, and then we can just take our function, the build and run graph function. I hope I'm spelling it correctly. Build and run graph. Yeah, build and run graph. So our build and run graph function, first we tell it what state schema we're working with. What state schema we're working with. We're working with a dictionary. So we give it the standard Python primitive dictionary. So we're working with that data type. And what's our initial state? What's our initial state? For that, I'm just going to give it this function so that it gets our initial state from this function. So we'll do this, we'll call the function. And now I'm going to pull up my command line. Let's clear this up. And now let us run this file. Python agent state.py. Let's run it. So here we're getting an error. And the error says that there's no module named LangGraph. Now that's just a silly mistake by me. I'm not in my virtual environment. So let us make sure that we're in the virtual environment before doing that. So I'm just going to activate it by saying source vmv.vmv rather bin activate. So now we're in our virtual environment. That's good. And we can run this file once again. Python agent state. And boom, yeah. Building and running graph with state schema dict. So we got the right data type that we're using, the dictionary. It says executing node A, executing node B. Current step count from state is 1. And the final state is this. step B completed, step count 1. So our step count is no longer 0, it's now 1. And our messages list says step B completed instead of just giving us an empty message. So we've been able to update our state through node A and node B. In node A, we set the step count to 1. And for the messages, we say step A completed, step count 1. Then for node B, we say step B completed, which is what we got in our final state. And the step count is also 1. Now you might be wondering, why don't we have step A completed and step B completed in our message list? And why is our step count not 2? Because we actually hopped through 2 nodes. Now that's because we're currently using the default reducer, and the default reducer is going to simply override the data in a particular state variable. It's going to override the entire data. So even step A made step count to be 1. It returned 1. So step count to be 1. And step B also returned 1. So step count will just be 1. There's no incrementing. For us to increment, we need to define a custom reducer. But let's go on. For now, we are here for state schemas, so let's just focus on that. And now we've been able to see the dictionary example. The next example we're going to look at is the typed dictionary example. That's the TypedDict example. Creating a state schema using TypedDict. For TypedDict, to make things fun, I'm going to be adding some custom reducers. So the first thing we're going to do is to import some helpers that we need, which includes TypedDict itself. So I'm going to say from typing, give me annotated, give me lists, and also give me TypedDict. So we have those 3 items that we're going to be using to create our schema. I'll also be needing the help of a useful LangGraph function called add messages. We're going to be talking more about add messages in another video, but it's basically a built-in reducer that LangGraph provides for you to manage LLM messages. So you can use it to manage a list of LLM messages. Basically, the most important use case of it is chat history. So you can use it to maintain your chat history. So I'm going to be bringing this in to define my schema using TypedDict. Now for the TypedDict schema, let's go down. Let's create a new section for a new example. We'll say using TypedDict. Now to create your schema using TypedDict, the first thing you need to do is create a class for your schema. I'm going to call it TypedDict state. And this is going to inherit the TypedDict class. Because you inherit that class, and here you can just go on defining your class members. And those are going to be your state variables. So first, let us start with messages. And one of the, or rather the main advantage of using type dictionary is that you can now use type ints. With a plain dictionary, you can use type ints, but if you define your state using type dictionary, you can use type ints. You can't set default values though, but you can use type ints. And TypedDict works seamlessly with LangGraph, so it's one of the recommended ways for you to create your state schemas. So for messages, we're going to annotate that variable. It's going to be a list of strings, and it is going to be managed using the add messages reducer. We also do step count. Now step count is going to be an integer still, but then we want to be able to update it to actually increment. We want to update it to increment. So what I'm going to do is that I'm going to create a custom reducer for this that's going to help us increment the value. So just above here, I'm just going to define, say, custom add. And reducers, basically, if you're going to define them yourself, they take in the current value of the state variable and the new value that is coming in. That's the new value that is being returned by a node. Those are the two things that they take. So for this, I'm going to say current. I expect it to be an integer. And new, which I also expect to be an integer. And definitely I want to return an integer, so that should kind of be implied. Now here I'm just going to return the summation of the two. That's just add the current to the new. So if the step count is currently 0 and we return 1, it's going to add it to 0, and that will be 1. If the step count is currently 1, if we add another 1, it's going to be 2. So we're just going to put this here. That's going to be our reducer. And yeah, you're seeing how to add reducers from this video, but like I said, we have a whole video on reducers that we are also going to use to drill down on these things. So step count, and finally we have private data, which we're still not interested in, so I'm just going to set it to a string for now. So now we have our state schema created with a type dictionary, and now we can use this example to build our graph and run it. So I'm going to say build. I'm just going to copy that. Build and run graph. Build and run graph. Now to run this, first we need to pass it our state. So we'll say TypedDict state. Pass our state schema, and then we pass it an initial state. Pass an initial state, which you can simply pass using a dictionary. So here we're going to say messages. For messages, we start with an empty list. Then next we have step count. Step count is going to be 0 to start with. Then we can do private data. And private data, we're just going to set it to an empty string. Set that to an empty string. So message is an empty list, step count 0, and private data is an empty string. So let's pull up our command line and let us run this file once again. Say Python agent state.py. Let's run this. And now we have executing A and B. Yeah, we get it. But these are our final states. These are our final states. And if you look at this, messages, we have a human message. We have a human message here, and when we check the content, we'll see step A completed. If you look into the list, you see another human message, and this content says step B completed. So, and now instead of having the messages list overridden by the most recent value, we now have both values inside for step A and for step B. And you might also wonder why we're having human message, why we're not just having a list of pure strings that just says step A completed and step B completed. And that's because we're using add messages as our reducer, and add messages is basically built for LLMs to update a message list. So that is why it is adding human messages from the LangChain messages class. So that's why we have that. That's why you're seeing this weirdness. But you can still use something like operator to just add your string input, and it will just add it as strings if that's what you want. If we look at step count this time, step count is now just 2. Step count is 2. It's not 1. That's because it is incrementing it. True node A incremented it by 1, so we had step count as 1, and true node B it incremented it by 1 again, and we have step count as 2. And private data stays empty. So yeah, that's working fine. Our LangGraph reducer is doing its thing. Our custom add reducer is also helping us manage our step count. So that's cool. Now let us go to our final example, which is using Pydantic. We're going to be using Pydantic, which is a very awesome library that you can use to define your schema, and it gives you validation, it gives you type ints, you can set default values and stuff like that. So we're going to be making use of that next. First, I'm going to clear the command line. Let's close out from this. I'm going to comment out this step. And we're going to create our third example, which is using Pydantic. Now to use Pydantic, first we need to bring in the library. Say from Pydantic, let us import base model, which our schema class is going to inherit from. And we're also going to import field, which is the exact class that's going to help us build up our state variables. Any extra information that we want to add to our state variables, field is going to help us do that. So we have those. I'm also going to be bringing base message from LangChain core messages. Going to be importing base message. because for our messages list, since we're going to be using add messages, we want to make sure that we are defining it with base message in Pydantic, because Pydantic has validation, and if we call it a list of strings and we are trying to add a message type from LangChain, it's going to throw an error. So we have base message, and now we can go down and use Pydantic to create our schema. So first we're going to create a class, and I'm going to call this Pydantic state. This is going to inherit from the base model class. Going to inherit from base model class, and then we can define our schema. We'll start with messages, set that to an annotated type. It's going to be a list of base message. It's going to be a list of base message, and we're going to be managing it using the add messages with user. So this is good, but we're using Pydantic, so we can do more. For the field, I'm going to set this as a default factory, and the default factory we call list. Now, why are we doing this? We want to make sure that every instance of this state class rather gets the new list. Else, Pydantic is going to share the list between as many instances as you create. We don't want that. We want every instance of this state to come with a fresh list. So that is why we're doing this. So we have that in place. Then for our step count, we're also going to define it similar to what we did with the type dictionary, custom add. But with Pydantic, we can use field to set a default. The default equals 0. Set the default. And lastly, for private data, which we have been ignoring, within our nodes, just going to set it as string, and we also add a default value to that. So we set it by default to an empty string. So now we've defined our state schema using Pydantic. We have a Pydantic state now. Now let us build and run it. Let us run it through our graph. So once again, we're going to come here and say build and run graph. Our state is Pydantic state, so we're going to give it that. And for our initial value, we just instantiate a new Pydantic state. So just we create a new instance of Pydantic state, and what it's going to do is just going to take all these defaults. So we've already set defaults, so it just takes the default. Step count is going to be 0. Private data is going to be an empty string, and we're going to get a fresh list for our messages list. So let's save this. Now let us run our code from the command line. Once again, and say Python agent state.py, and boom, yeah, our code runs. Node A is executed, node B is executed, and for our final state, we have our list of messages once again, with step A and step B completed. Our step count is 2, and our private data remains empty because in our node we're not touching our private data. So in this demo, we have been able to use a plain dictionary. Use a plain dictionary for our state schema, the Python primitive dictionary data type. Then also we use a type dictionary, and we started adding with users so that we can actually see how state is updated. And we finally used a Pydantic model, a Pydantic based model, to define the schema for our agent. So these are options you can use. Data class is also an option, so if that works for you, you can also use that. Data class and type dictionary works. They are faster, they are more efficient than Pydantic, but Pydantic gives you more options. So and most of the time, I don't think the performance hits that you get from Pydantic are going to be really severe. But if it starts piling up, then you know where that optimization task can come from. TypedDict and data class, they are more performant than Pydantic, but Pydantic gives you more options. So that's how you define your state schema in a LangGraph graph.